Good day to all. Today we are going to see about that Kirchhoff's current law. First, Kirchhoff current law introduction, then the nodal analysis we will going to see. See the Kirchhoff's current law introductions. The Kirchhoff's current law, sometimes also called Kirchhoff's first law or Kirchhoff's junction rule. Maybe in that exam they will ask about the Kirchhoff's first law or a Kirchhoff's junction rule. Then in this position it will be shown how Kirchhoff's current law describes the current flow through a junction of a circuit. Along with the Kirchhoff's voltage law makes up the two fundamental law of electrical engineering. See, the third one is Kirchhoff's current law helps to solve unknowns when working with the electrical circuits, and this Kirchhoff's current law with the addition of Kirchhoff voltage law and Ohm's law will allow for the solution of complex circuits. The definition of Kirchhoff's current law is, you can see here, a junction. A junction is any point in a circuit where two or more circuit path comes together. So, what is the meaning of junction? Junction means if it is a connection of 2 points or more than 2 points. See, if it is in a single point, we cannot say this as a junction. This is only straight line, like we can say. If it is more than 1 point, if it is 2 or 3 or 5, then we will say this as a junction. These are the example of that junction. You can see here there are 2 points come over here. This point and this point will come over here. Here you can see 4 point will come from that voltage, and from that this R5 and this R4, then R6. There are more than 4 points will come over here. This is called a junction. This is the two junction, and this have a more than 4. Then now we will see about that Kirchhoff's current law. The algebraic sum of the all current entering and leaving at any point in a junction in a circuit must equal to 0. See, the algebraic sum of the all currents entering and leaving at any point, which means junction in a circuit, must equal to 0. Here, positive indicates that the current is entering into the junction. If current is entering into the junction, we can tell it as a positive. If it is leaving from that particular junction, if it is leaving means we will say as that negative sign. So the junction, as we said earlier, if it is a point have a more than one connection, that will called also junction. Here you can see this junction point. This junction point have a resistance 1, and the I3 also come. The voltage is leaving, then the current I2 also come. So for this, how we can write that Kirchhoff's current law? You can see sigma n into In for current In equal to In I1 plus I2 plus I3 plus I4 equal to 0. Here the thing is, see, you can see what we are saying before, the algebraic sum of all current entering and leaving at a junction at a point must be equal to 0. So how we can write this one? Here we will write, see here, what are all the incoming current over here? Here I2 is incoming current. So we'll have a plus I2. Then what is that incoming current? We'll have a plus I3. Okay. This is the positive sign we will get. And it is equal to, what are the negative sign is over here? I1, it is leaving from the junction. So we will put as minus I1. Then the other I4 is leaving from here. So minus I4. So this I2 plus I3, if this I minus sign overcome here means plus I1 and plus I4, which is equal to 0 over here. That is the concept of this Kirchhoff's current law. The algebraic sum of the currents entering and leaving at a point as a junction is the circuit must be equal to 0. We can say like this also, algebraic sum of currents in a junction is equal to sum of current and out the top current, which means sum of incoming current. For example, if it is a junction, sum of incoming current, these two is incoming current, is equal to sum of outgoing current. If these are all the outgoing current, these also we can say the Kirchhoff's current law. See, the algebraic sum of all currents entering and leaving junction is must be equal to 0, as we said earlier. Here you can see this is the junction point. This is the junction point, and the current entering the node is equal to current leaving the node. Incoming current is equal to outgoing current, right? Here you can see here in this node, what are all the incoming current? This I1, see the arrow, this is incoming current, and this I2 also incoming current, this I3 also incoming current, this I4 it's outgoing current, and this I5 also outgoing current. You will see the arrow mark, it is the outgoing current. So how we can write this current? As we said, the incoming current is equal to outgoing current. So we can write as I1 plus I2 plus I3, which is equal to I4 plus I5. Right? Because these I1, I2, I3, this I1, I2, I3 is incoming current, which is equal to this outgoing current I4 and I5. So I written as I1 plus I2 plus I3, which is equal to I4 and I5. If it is equal, then if the I4 and I5 come here, what will happen? Likewise, here it's denoted the same. This I1 and I2, I3 is equal to I4 plus I5, right? If this I4 and I5 come over here, means it will take as a negative sign. That's written over here. See, I1 plus I2 plus I3 plus minus of I4 and minus of I5 is equal to 0. Then here the three currents are entering at the node. That three currents, as I said, I1, I2, I3 are the positive value. Why? Because these are all incoming current. If it is that incoming current for a particular road, we will take that current as a positive sign. Then two currents leaving the node, I4 and I5, are negative in value because these are all leaving from that node, so we will take as a negative. Then this means we can also rewrite the above this equation like I1 plus I2 plus I3 minus I4 minus I5 is equal to 0, because These two, I4 and I5, is leaving from that particular node. So we can directly return like I minus I4 minus I5. This is the algebraic sum of all currents entering and leaving at the particular this junction point. These are all about the Kirchhoff's current law. Thank you.